Hello everyone, I am N. Raju Balakrishnan from ECE department, Excel Engineering College. Today we are going to discuss the topic about shift registers and ring counters. So first of all we want to know about registers. Yes, register in the sense it is called the storage elements. Yes, so it is going to store the bits and as well as it is going to shift the bits. That's why it is called as shift registers. Okay, counter in the sense it is going to count the operation. That's why it is called as counters. Okay, so next. So shift register mostly it is going to use it for that is called shifting the operation from one places to another places. So that is called many type of digital systems we are going to use for shift registers, and especially for packet calculator. So that is we are going to share the data from one places to another place. That particular time the data bits can be stored as per the packets. Okay, that's why in that particular data packet we are going to calculate by the help of shift registers. Okay, so here first of all we want to design the shift registers. We want to know about flip-flops. So by the help of flip-flops or IC only we are going to develop the shift registers. So generally we are going to use for D flip-flop. So that is called a direct flip-flop. So whenever we are going to give the input for 1, so during the clock pulse it can produce the output the same. Yes, so that is the D flip-flop. So by the help of D flip-flops we can develop the shift registers. There are based on the number of flip-flops, the bits also we are going to use for the inputs. Okay, so example we are going to design for 4-bit shift registers. That particular time we are going to use for 4 type of flip-flops. There is 4 same type of flip-flops. In case we are going to use for 5 bits shift register, that particular case there are 5 flip-flops we are going to use. So here there are 4 flip-flops we are going to use. So that is all flip-flops are D flip-flop. Okay, so first, second, third, fourth, that's why we are going to choose the 4 inputs 1 0 0 0. This is our inputs. So we are going to apply the input for each and every flip-flop. It can, based on the clock pulse, it can produce the outputs. Okay, so whenever we are going to apply the clock pulse, all the flip-flops are simultaneously going to function. Then it is going to shift the data bits from one position to another position. So that's why it called as shift registers. Okay, next. Yeah, here first of all we are going to apply the clock pulse for that. This is the input 1 0 0 0. So this is the clock pulse. We are going to apply the clock pulse for that. So what will happen? So the particular flip-flop going to start to function. All the flip-flops going to start to function. Okay, but in initial case does not get any inputs. So how the data bits can process in the sense from LSP to MSP. So first bit, what is the first bit? That is 0. That is LSP bit is called 0. So that is the first bit that is given for first flip-flop D. So that during the first clock pulse only the particular flip-flop only got the input value. So based on the input it can shifted from D to Q. So the data bit can be shifted here. Okay, so whenever we are going to apply the second clock pulse, what will happen in the sense? So that is the second input. The second input also 0. So already here that particular flip-flop got the output, that is 0 here. So that particular there are 2 flip-flops got the inputs, it can shift it. So likewise that shifting operation going to function. Okay, next. So while we are going to apply the third clock pulse, what will happen? So here 0, that is the input, third input is 0, then previous output 0, the previous output 0. So that means there are 3 flip-flops got the input, then it is going to shift the output. So what will happen? Here the output is 0, here output is 0, here output is 0. Okay, so then we are going to apply the fourth clock pulse. What will happen? So that is the first input is called 1, then 0 0 0. That means 1 0 0. So while applying the fourth clock pulse, the first output we are going to get. So that's why it called as shift registers. That is shifting the operation. So that's why it called as shift registers. Okay, next. Yeah, so there are 4 type of shift registers are there: serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. So serial in, serial out in the sense we are going to apply the input in serial manner, we are going to get the output also in serial manner. So that's why it called as serial in, serial out. So that means, so number of bits we are going to apply in serial manner, number of bits we are going to get in serial manner. That's why it called as serial in, serial out. So next one is called serial in, parallel out. So serial in, parallel out in the sense we are going to apply the input in serial manner, but we got the output in parallel manner. Compared to this one, that is serial in, serial out. Serial in, parallel out is called quick processor. Okay, because of parallel we are going to get the output. So next one is called parallel in, serial out. So that means we are going to apply the input in parallel, but we got the output in serial manner. That's why it called as parallel in, serial out. The last type is called parallel in parallel out. That means we are going to apply the input also parallel, we got the output also parallel. That's why it's called as parallel in parallel out. So we are going to explain in detail about types of shift registers. Next. So this is called we are going to choose, there are 4 bit shift registers. Next page. Yeah. So here there are 5 bits. That means we are going to taken for 5 bits. So that's why it called as, there are 5 flip-flops we are going to taken. So all the flip-flops are D. So D0, D1, D2, D3, D4. So that means 5 bit we are going to apply in particular time. So here the values, there is the inputs. So this is the clock pulse, common clock pulse applied for all flip-flops. Then only we are going to process for, or we are going to generate the shift registers. Okay. So next one. So next one. So we are going to apply the inputs, first bits, that is called 1. So while applying the clock pulse 1, so what happened? So only the particular flip-flop only got the output, inputs. So that is called LSB bit. The LSB bit 1 going to shifted here. Okay. So next. So while applying the second clock pulse, what happened? So that particular, the second flip-flop only got the input. So that's why the second bit going to shifted to next position. Next. So while applying the third clock pulse, what happened? So that is the third clock pulse only got the input. That's why that value can be shifted. Next. While applying the fourth clock pulse, the fourth flip-flop only got the input. So that's why that bits can be shifted. So while applying next. So while applying the last, that is for fifth clock pulse. So that is 5 bit shift register. That's why the fifth clock pulse it got the outputs. So this is the serial in, serial out. So while applying the clock pulse, so that bits can be shifted. So here the Q0, Q1, Q2, Q3, Q4. So this is called the output of flip-flops. So this is the clock pulse, this is the inputs. So first of all we are going to take the input for 1, 1, 0, 1, 0. So this is the inputs. So we are going to apply the first clock pulse. What happened? Only the Q0 value is 1. The remaining things are 0. So while applying the second clock pulse, that is called Q1 is 1. So that is while applying the third clock pulse, Q2 is 1. So while applying the fourth clock pulse, Q3 is 1. So while applying last clock pulse, that is fifth clock pulse, Q4 is 1. So likewise the value can be shifted. So that's why it called as serial in, serial out. Next. Yeah, next type is called serial in, parallel out. So that means we are going to apply the input in serial manner, but we are going to got the output in parallel manner. So this is the input D. So these are all the 4 flip-flops we are going to taken for serial in, parallel out. So here common clock pulse applied for all flip-flops. So we are going to apply the input here. So but we are going to each and every stage we are going to get the output. So that is called Q0, Q1, Q2, Q3. So everything we are going to get the outputs. Next one. Yeah. So there are 4 flip-flops. We are going to apply the inputs here. So that is the first input we are going to apply. So while applying the first clock pulse, what will happen next? What will happen? So next. So first clock pulse, that is Q0 going to proceed the outputs. So that is first stage itself we are going to get the output. So that is Q0 value. So then next. So while applying the next bits, that is called 1, that is next position, 0 shifted to here. So that is the second output. That particular case what will happen? That Q0 also get the output, the same time Q1 also get the output. That is we are going to apply the second clock pulse. While applying the second clock pulse, that particular time we are going to get that there are 2 outputs. So next. So while applying the third clock pulse, so the third 3 registers going to proceed the output, provide the outputs. Next. While applying the fourth clock pulse, all the flip-flops can produce the output. That is the inputs for 1, 1, 0, 1. That is the input we are going to taken for assumption. Okay. So in case we are going to take some other example, that is also can proceed the same process. Next. Next. Yeah. So next, yeah, this is the process. Next one. So that is the input 1, 0, 1, 1. Okay. So this is the timing diagram. The same thing. So we are going to apply the data. That is here 0, 1, 1, 0. Because so we already know this is the example here. So this is the clock pulse. While applying the clock pulse, what will happen? So there is the data input is 0. So that particular time what will happen? While applying the first clock pulse, Q0 value is 0. Because based on the input, it can produce the outputs. So while applying the clock pulse, there is next clock pulse, the data input is 1. So that particular time, Q0 value also 1. So while applying the clock, there is data input is 1. The third clock pulse also, that Q0 value is 1. So the same way, the same process can separate next position. So that's why it called as serial in parallel. Next. So next type of shift register is called parallel in serial out. So parallelly we are going to apply the input. It can produce the output in serial manner. Okay. So here this is the parallel processor. So this is also one type of parallel processor. This is also one type of parallel processor. So here the shift and load concept we are going to apply here. So while applying the shift value is equal to 1, so that particular time the value can be shifted from one position to another position. While we are going to apply here 0, so that time what happen? So that is the load operation. So that's why it called as NOT gate. Okay. So here clock pulse we are going to apply for each and every clock pulse. Sorry, every flip flops. So then input also we are going to apply in parallel manner, but that output is going to get after fourth clock pulse. Okay. So here we are going to apply the next. Yeah. So this is the clock. There is clock pulse. Then shift and load. So the shift in the sense it going to shift the inputs. Load in the sense it going to store the values. Okay. So first of all, clock pulse is 1. So the load value, that is 0 in the sense what? That is load. Okay. That time what happen? So the data values can be load. So next what happen? The same clock pulse, the shift value is 1. So the time that output also going to get 1. So like with that operation can be shifted. But what happen in the sense? So we going to apply the input in parallel manner, but we going to got the output in serial manner. Okay. Next. So last type of shift register is called a parallel in, parallel out. So this is the very quick process compared to remaining 3 types, because so within the single clock pulse it can produce the outputs. So we are going to apply the input in serial, that is parallel manner. The same time we are going to get the output also in parallel manner. So common clock pulse applied for each and every flip flops. So we are going to apply input is equal to 1 0 1 0. So at the time, so we are going to apply the single clock pulse. What will happen? All the flip flops can produce the output, that is 1 0 1 0. So that's why it called as quick processor. Next. Yeah, this is next type is called counter. We know about counter. So counter, what is the need of counter in the sense it going to count the sequence. So there is many type of operation going to perform the many type of industries. Yes, that particular case by the help of digital ring counter we going to count the operation, sequence of operation. Okay, so here number of flip flops we going to use based on the counter values. Okay, so example here there is around 8 flip flops we going 9 flip flops we going to use. Okay, Q0 to Q9 there is 10 flip flops we going to use. So that means 10 bit ring counter. This is called 10 bit ring counter. So that means that is everything is 0 0 0. That is the first processor. Example, it going to count around 100 of sequence of operation. Okay, so there is 2 power 10. 2 power 10. That what is the value? That is that much of value going to count. Okay, so that is what is that ring. So what is the ring in the sense? So that is called we know about ring. Yes, so there is no starting and as well as no ending. So that's why it is called ring. So that is output again connected to input. That is it cannot stop the operation. It going to continuously sequentially going to find. So unlimited value can be find. That's why it called as ring counters. So first of all we going to assume some values for d values 0 0 0 0 0 like that. What happened in the sense each and every clock pulse it can be count the operation. So that's why it called as ring counters. Next. Yeah. So this is called ring counter. So values for 0 there is clock pulse Q0, Q1, Q2, Q3, Q4, Q5, 6, there is Q9 up to there is 10 registers. We are going to apply that. So it starts from 1 0 0 0 0, then 0 1 0 0 0 0, then that is that while we are going to apply the same clock pulse only Q2 is equal to 1. So while applying the third clock pulse Q3 is equal to 1. So that means based on the sequence it is going to find the operation. Okay, so that is 1 1 1. That is while applying the 9th clock pulse, so only the 9th value is 1. Remaining things are 0. So based on that we are going to find the number of sequence. Next. Yeah, this is the timing diagram for previous representation. Next. Yeah, thank you.